Hello, my name is Leo Rivera. I'm the Director of Scientific Outreach here at Meter Group. And today we are going to talk about methods for measuring hydraulic conductivity. One of the first things I think we really want to think about when we're measuring hydraulic conductivity is, one, there's a lot of tools out there that help us make this measurement. And there's a couple things you want to think about when it comes to making the measurement to make the right choice for the tools you use. So the first thing that you want to think about is understanding the difference between lab versus field methods. So here on the left, we have two instruments that are great for making measurements of hydraulic conductivity in the lab. And on the right, we have a device that is a great tool for measuring hydraulic conductivity in the field. But there's a couple differences that you need to understand. The first difference is when we're making measurements in the lab, we're making measurements of a point sample. So for our lab devices, we're typically taking a core sample like this from the field, and that is what we're going to be making our measurements on. So as you can imagine, when you think about where that sample is coming from, that this is a point within the soil profile. When we're making measurements in the field, we're typically taking a measurement from the surface and we're infiltrating water down through the surface through a ring like this that's driven into the soil. So when it comes to making those measurements in the lab versus the field, sometimes we see differences because of how the sample is taken and what that sample actually represents. Typically, the field measurements represent water movement through a profile. We're integrating all of the soil in that profile where that wetting front is moving through. And for lab measurements, it's very select to that point of where we're taking the measurement. Some other things that come into play when it comes to lab measurements is we do see differences just in how the pore structure is made up. And when you take samples, you wind up sometimes with open-ended pores that can impact how that measurement looks. So now we're going to dive into some of the different methods for making these measurements and some of the nuances and things you want to think about when it comes to the measurements and the tools you use. So first, we're going to focus on the laboratory methods and talk about some of the different measurements that you're going to try and make. And the first thing you want to think about is, what am I trying to measure? So typically, we're either looking at saturated hydraulic conductivity in the field using a device like this, where we have that core sample that's been saturated, and then we're measuring how fast the water infiltrates into the core or through the sample using either a falling head or a constant head method, which with a tool like the KSAT, you can do both. And then we're doing some corrections to that based on the pressure heads and just some geometry things that we need to correct for after the measurement's done. So that's a tool like this, or we're using a tool like the HYPROP, where we have tensiometers positioned at two different points within the core, and we're measuring as that sample is evaporating. And we're measuring the unsaturated hydraulic conductivity with a tool like this. So you're getting two different measurements, and these are the tools that we would use to actually help generate that hydraulic conductivity curve. When we're trying to generate that hydraulic conductivity curve and fully characterize the soils, these are great tools because, again, we can be selective in what layer of soil we're characterizing and take a sample from that layer and then fully characterize that sample, getting both the saturated and unsaturated hydraulic properties of that sample. So on the other end of that, we have our field methods for measuring hydraulic conductivity. And there's a lot of tools out there for making these measurements. There's double ring infiltrometers, single ring infiltrometers. We have borehole methods as well. Today, we're going to focus on a ring infiltrometer like this. This device is the SATURO. It is a dual head infiltrometer, and it's a single ring infiltrometer. And so what we're doing is driving this ring into the ground, typically to a 5 centimeter insertion depth or a 10 centimeter insertion depth, and we're measuring as the water infiltrates. So as the water is infiltrating, we're measuring that rate of flow into the infiltrometer. With a device like this, we're using what we call the dual head method, which allows us to also easily correct for the lateral flow that we see from a single ring infiltrometer. And so that's another thing that you have to think about when we're comparing methods in the lab versus the field. There are different corrections that we have to make. You don't have to make corrections for three-dimensional flow in the lab, but you do have to do that in the field. And so sometimes that can complicate things. And if you're not using the right tool that helps make it a little bit easier to correct for those things, that can create a little more error in your measurements if you're not careful. But using tools like the SATURO with the dual head approach, it simplifies that correction for us, making it easier for us to go from the infiltration data that we get from this to the saturated hydraulic conductivity or the field saturated hydraulic conductivity, which is what we're ultimately trying to get. So I've presented a few different tools here and a few things for you to think about when it comes to making these measurements. And you have a lot of options to choose from. And I just want to give you some things to think about when it comes to which sensor to use for your application. And the rule of thumb I always like to give to people is if you're trying to characterize water flux in the field and how water infiltrates through the soil, it's typically better to go with a field method like this, because what you're doing is actually characterizing how water infiltrates from the surface and getting that measurement and that characteristic of the soil. If you're trying to delineate the different layers and better understand at different points in the soil, what do those hydraulic characteristics look like, then I would recommend using laboratory methods like this, because again, you can get down to those individual layers and characterize them. And then this also allows you to more easily fully characterize the hydraulic properties of a specific soil layer or specific soil type, which can sometimes be a little more challenging in the field. We do also have tools for making field measurements that allow us to do unsaturated hydraulic conductivity, like tension infiltrometers that we can use to try and generate that same hydraulic conductivity function in the field, but it can be a little more challenging to do that. And so sometimes it's a little easier to do that with laboratory measurements.